Hi everyone. In today's video, let's take a look at a very important library in Python called NumPy. So NumPy is a very important library and you will use this library for many mathematical and statistical computations, and also they are very useful for quick data processing of data and for vectorization. So let's take a look at this library in detail with some practical examples, and let's take a look at the basics so that you can understand this library. Very important, and it's fundamental to understand this library because many data analysis libraries are built upon this library. I'll be using Jupyter Notebook for this tutorial and I'll be coding everything along live so you can follow along with me as we go. If you have not installed Jupyter Notebook, I'll leave a link to the video I made on how to configure your Jupyter Notebook and your different environments so you can follow along. So let's take a look at this. First, you need to install NumPy. So open your Python command terminal, and install this. If you don't have it installed, you can run the pip command. So pip install NumPy. You can install this in your command terminal once you have Python installed, and this should install NumPy for you. After this, you need to import this into your environment. So we'll do import NumPy as NP. It's very good to alias it so that once you import this, you can then refer to the alias, and all the functions and the modules can be accessed to the alias. Okay, so I've imported that. Now let's go to the next cell and let's see what we can do here. Now, say you have a list object in Python. Let's take a look at a list data structure. Say list 1. A list of numbers, and I have list 2, which is also a list of numbers. Now say you want to do some mathematical operations on this list. Say you want to multiply each element of the list together. It will be quite cumbersome to do this in traditional list objects. I will have to write a for loop and loop through the elements and then do that. But I can do this easily using vectors or arrays in NumPy. Vectorization is the process in which you can operate simultaneously on different data elements in the list without having to operate on them individually. So I can multiply each elements of these two lists together using vectorization, and this simultaneous processes, when I operate on all these elements together, helps improving the computing power and helps improve your processing speed, especially when you're working with large amount of data. So let's take a look on how to do this. So now what I'll do is, I need to create an array object using the NumPy library. So I can say array 1, and let's do it. I need to call np dot array, and I can pass this same list object that we have created. Okay, and let me do another array 2 equal to np dot array, and pass this list object 2. Okay, I run this. Now if I do, let's take a new array 3, and I can do the product of both of these two arrays. So let's say array 1 multiplied by array 2, and if I display array 3, you can see it gives me an array which is a product of multiplying each element in the first two arrays. So 2 into 3 is 6, 3 into 4 is 12, 4 5s are 20. Right? So I can easily do this operation using the array operators. You can see the power of NumPy. Now let's take a look at something else. That this is a one-dimensional array that we have created, two one-dimensional arrays. Let's take a look at a two-dimensional arrays. A two-dimensional arrays, you can think of it as somewhat as a table having multiple rows and columns. Let's create a two-dimensional array. Let me call np.array function. Okay, and in this function, let us create a two-dimensional array. So that is basically I need to pass a list of a list. So let us say this is my first row, and I'm just going to indent it properly so that you can understand it more clearly. And let's say this is my second row. Okay. Now if I run this, and let's call this 2D, and you can see now, okay, oh, there's a spelling mistake here, so let's run this again. All right, so now you can see this has created a 2D array. Okay, it has 2 rows and 3 columns. I can check that further by doing the, let's check the dimensions of the array first. You can do ndim, will give you the dimensions of the array, which shows 2-dimensional array. And now if I want to see the shape of the array, so I can do shape, and I run this, and it shows me it's an array of 2 rows and 3 columns. So it's very useful to think of this, because you can manipulate your data here. And again, I've stored the array of integers. You can do this for string as well. Okay, so I could have created this table of 2 rows and 3 columns which are of type string. So if I see the type here right now, so basically I can easily use this to represent tabular data. So I can dtype, and it will show me this is of type integer, right? So now let's take a look at a more powerful and a little more complex array structure. That's a 3-dimensional array. Mostly in data projects you will be working on 3-dimensional arrays, unless you are using you are planning to write some complex algorithms or mathematical computational type problems where you're going to use different algorithms or create your own algorithms. You may mostly work with data up to 3 dimensions, but for other tasks you may require more dimensions as well. But the beauty of NumPy is it gives you n-dimensional array, so you can create array of any dimension. So let's take a look at a 3-dimensional array. And so this, you can think of it as a multiple tables with multiple rows and columns. That's why I said for most data projects you will have generally multiple tables and multiple rows and columns. So let's create the first table first. So to simplify the creation, okay, let's do that. And what we did in the first, I'm going to just copy this, okay, so that it minimizes the task. Okay, I just replace some numbers here so that when we call it, we can easily see. And this can represent your first table. Now I need another table. Okay. So let's copy this again. For clarity purposes, I'm just indenting it so that you can clearly see. Okay. Sorry. All right. Okay. Now, so you can think of this as your table 1 and this as your table 2. Let us add one more row so that we have a better clarity on this. Okay. So let's add one more row. Let's indent this properly. Adding one more row so that we can understand this better. Okay, let's run this, and now let us call this array. You see this can be thought of as 2 tables. This is the first table, this is the second table, and each table has 3 rows and 3 columns. Again, you can verify this as what we have seen earlier. You can say array 3d dot ndim, and it will show you 3 dimensions, and you can say array 3d dot shape, and it will show you it's basically 2 tables, and each table has 3 rows and 3 columns. So you can see how easily you can work with data. You can work with multiple rows and columns, multiple tables even with multiple rows and columns. You're beginning to see the kind of flexibility on how you can arrange your data, and you can work with your data in using NumPy for different mathematical computations as well as for data analysis processes. Now let's take a look at something else. That let's say we want to do slicing of data. Now we have seen how you can manipulate the data, but how to index your data, or how you can slice your data or retrieve elements from your data or your NumPy array. Let's take a look at a simple example first. Say this, let's say array 1 we created, and then we'll go to more complex examples. This is array 1. I want to access the element at position 1. Python starts at 0 based indexing, so the first element is at position 0, then 1, then 2. So let me access the element at position 1. You can see it can access that. Now let's take a look at a different mode. The indexing follows the similar methodology that we use for list objects in Python, which I've covered in my previous videos. You can look at the shorts, but it follows the similar principles. So now let's say I want to access the 2-dimensional array. So you can think of a 2-dimensional array as a table with rows and columns. Say I want to access only the first row. So that means the row at position 0. I can pass this. Now say I want to access the row at position number 1. You can see. So now say I want to access the column. Okay, I want to access the column. So I want to access all the rows. Okay, all the rows and the column at position 1. So I can do 1 to 2. You can see you can access the column at position 1. So you can you get the idea how you can access the rows and columns. Let's take a look at a 3D array. As I mentioned, the 3D array can be considered as tables of rows and columns. So in this case, if I want to access the first table only, just pass the index at position 0. You can access the first table. You can see. Now I want to access the first table, and I want to access the first row of that table and all the columns. You can see it does that. It's at position 1. If I want to access the first row at position 0, you can do that. I want to slice some data. Say I want to do it for the table at position 1. So I can do that. I can change that. This is table at position 0 at the first table. The table at index position 1 is the second table. So I'll do this, the table at position 1, and I want to slice a portion of this. So I want to say for the for the rows 0 to 2, and for the columns again 0 to 2. And you can see it has sliced only this portion. So you can see how powerful it is. I can slice any part of my data. I can do a horizontal slice, I can do a vertical slice, and I can do a portion of the data. Right? Now once you have done this, you want to assign values to your data. So I want to override. So as we said, a list is a NumPy array is partially mutable, meaning you can change the values, but you cannot add a new value. To add a new value, you have to reassign to the NumPy array again. So let's get the values for this, and I get the first row and all the columns. Sorry, the index and the row at position 0 and all the columns. Okay. Now I want to reassign this. So let me assign this to some value. Let me make it 1, 1, 1. Okay. Now we enter this, and if I execute this array again, we can see I've been able to change the row of the first table, right? Or the table at the index position 0, and I have changed the row at the index position 0 of the table at the index position 0. So this is how powerful it is. You can change the columns, you can change a portion of the data by extracting that data, slicing it, and then assigning the values you want. Okay. When doing mathematical computations, you also require zeros and ones in the form of matrices to do computations. So let's see how you can do that. You can do this and pass a tuple. So I want a 0 matrix of 2 by 3. I can do that. I can also do something like I want ones. This will help you in a lot of mathematical and matrix operations. Dot ones. Okay, and you can see that again I will give the dimensions 3 by 3, and you can see that. Okay, you can also do something that you can transpose your matrix. So let's see, I have a 2D array and I want to transpose them, convert the rows into columns. It will do that. So these are the powerful operations that you can do with your NumPy array. Then there are also different other things, like you can do statistical operations. Say for the array 2D, I want to find the sum. Okay, I can do the sum of all the elements. I want to find something like the max. max, the max element of this array. Can do that, and also I want to find the standard deviation or the minimum or the mean. So let's see, do the last standard deviation. Okay, you can do the mean. So this will show you how dispersed your data is. Okay, so you can see, you can do all statistical operations, and so this is how you can manipulate a lot of your data, and how you can use NumPy array for your statistical computation, mathematical computation, and for your data analysis. A lot of powerful libraries are built on this, like pandas. So very important to know the basics and fundamentals of how the NumPy library and the arrays work. If you like my video, please do like and leave a comment, and also do not forget to subscribe to my channel. Thank you.